Pre-algebra students, so as you saw from today's inquiry lesson, we are going to be graphing proportional relationships. Okay, so hopefully you have your guided notes out and you are ready to go. Okay, so I've set up our guided notes today in 4 little quadrants. So we have the story problem, and then putting that story problem into a ratio table, and then what that looks like is an equation, and then finally we're going to be graphing what that looks like at the end. Okay, so the story for this problem is if 1 cup of rice, my bad about the typo, 1 cup of rice feeds 3 people, how many cups of rice are needed for 9 people? All right, so we're using a pretty simple problem that I know you can probably solve mentally, but it's just to illustrate the larger point of how you can graph these proportional relationships. So we might set up this as a proportion and solve. So 1 cup per every 3 people, and we want to know how many will be needed for 9 people. So we can set up our proportion that way and then solve for x. Okay, so we know that to go from 3 to 9, we are making that 3 times bigger. So times 3. And then we would need to do the same thing to the numerator. Times 3. So in this case, x is equal to 3. So to feed 9 people, we would need 3 cups of rice. All right, now we can take that proportional relationship and graph it in, place it in a ratio table. So using those same strategies that we did for solving ratio problems, we're going to use that same idea. All right, so let's do, first of all, if I had no rice, how many people would I be able to feed? Obviously, that would be 0 people. Now, they give us the amount, and we're just going to go sequentially. 1 cup of rice is going to feed 3 people. And then we know, and I'm going to skip down, the question asks us about 9 people, so that would require 3 cups of rice. So therefore, we can kind of fill in 2 cups of rice would feed 6 people, and then following that same pattern, 4 cups of rice would feed 12 people. Okay, so we can see that in our rice column, this ratio, or this part of the ratio is increasing by a scale factor of 1 each time. So 1, 2, 3, 4. Whereas this side is skip counting by 3s. So going from 0 to 3 to 6 to 9 to 12. And we could continue these patterns infinitely. All right, you'll also notice here that on the label, I have put as the rice a little x, and for people, a little y. This is going to be clearer later when we connect this ratio table with our graph. So this would be the input, where it would fall on the x-axis, and this would be the output of where then that would fall on the y-axis. You'll also hear this called as the independent and the dependent variables. So this is the independent one, so meaning like I have this much rice, and then how many people that feeds is dependent on how much there is. Okay, so the next thing we're going to do is we're going to go over to the equation part. Now, this looks a little scary, but I think you'll find once we go through it, it's not so bad. All right, so we have y equals kx, and you're probably thinking, oh my gosh, what is that? All right, so we have the y. It's by itself on one side. We're saying that whatever the y value is going to be dependent on whatever is happening over here. So that means the x value, so that input, is going to be multiplied by this k value. So this is defining basically what the in-out rule is of this ratio table. So we're going to write that here. In-out rule. All right, now we actually already have found the in-out rule here. So to go from this ratio to that equivalent ratio, we've multiplied it by 3. And notice here, times 3 times 3 times 3. So that is the in-out rule. We also know that that is also the unit rate. So for one serving of rice or 1 cup of rice, it would feed 3 people. Now, in terms of this equation, this K has a special name. This is called the constant of proportionality. Now, it's not super important that you memorize that term, but just so you know, this is called the constant of proportionality, and it's also going to be the slope of the line once we graph it. Okay? All right, so if we look at this proportion and the ratio table, we can see that the value of K, or our in and out rule, or our unit rate, is going to be 3. So this proportion is the equation y equals 3x, meaning whatever value of x I plug into here, if I multiply that value by 3, it's going to give me the output, or the y. Okay, so let me just go ahead and label this some arrows. There we go. So all of this is that K. And then we have this special little thing here, that constant of proportionality, or that slope of that line. So you're multiplying x times 3, which we know is going to be the same as, actually, you know what, I'm going to use some different colors here because this is kind of important. 3 over 1. Okay, and this 3 over 1 is going to be the slope of the line, and here's a new term. This is going to be the line's rise over the run. Now, this will make sense. What these terms mean are going to make sense when we jump over here to the graph. So hold on to that confusion right now. I know you're probably thinking, what on earth is that? Okay, so going over to our graph, we can take the in and the out from our ratio table and plot it on a coordinate grid. So if we were to take the x, or the cups of rice, we could label that here. So let's use green. Cups of rice. And then we could label with our numbers 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. And then the y-axis is the number of people it feeds. So I'm going to go ahead and label that. Number of people, and I'm going to do my scaling. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have that all set up. And now I am going to start plotting these points and using this equation to draw my line, or to show that proportional relationship. All right, so first of all, I can see that it starts at the point 0, 0. Every proportional relationship will start at 0, 0. Then we are going to plot the first coordinate pair, 1 and 3. So I'm going to go over 1 and up 3. And that's the coordinate pair 1, 3. Now I have 2, 6, so 2, and then 6. And then the next one, 3, 9. And then it would be 4, 12, and it goes off the grid a bit, and that's okay. Okay, now, what was all that business with rise over run stuff? All right, this is also the slope of the line. So 3 over 1. That means I don't need to continue my ratio table. I can just follow this pattern, and I know exactly where my line is going to go. If I, from any given point, I rise up that many, 1, 2, 3, and then I run over 1 in the positive direction, 1 over. So another rise, 1, 2, 3, over my run, 1 over 1. Now, When you get into some more complicated linear equations, you'll find that there might be a negative rise, in which case you'd go down, or there might be a negative run, in which case you would go that way. But for now, for these proportional relationships, you're always going to have them be rise going up and then run going to the right, meaning that it's increasing each time. Now, if I were to know, let's say they were to have given me 4 cups of rice for 12 people, I could then use my rise over run in the opposite direction to determine how many people could be fed with smaller units of rice. So I could go down 1, 2, 3, and then over 1, down 1, 2, 3, and then over 1. Okay, so I'm going to go ahead and I'm going to take those points and I'm going to connect them. There we go. And I'm going to draw an arrow to show that it continues in that direction. And just for your reference, I'm going to mark that rise. Up 3, up 3, up 3. It's always going to be up 3. And then over 1 for this proportional relationship, because the in-out rule is times 3. Now this is a nice, neat, tidy one. Sometimes your in-out rule is going to be a little bit trickier, like times 2/3, in which case your rise over run would be 2 over 3, in which case you'd go up 2 and over 3. So just be aware of that. Okay, so that was a lot of information all at once. So we're going to have a lot of days where we practice graphing these proportional relationships. You can always, though, use this as your point of reference to help you out, as well as I'm available for office hours. Okay, so go ahead and get started on that practice set, and let me know if you have any questions. All right, good luck.